The Nash bargaining solution is an important concept in the economics of gender in developing countries. The notion is especially important for understanding households where we have typically two people, the husband and wife, but we could also imagine the parents and the children, or the children and grandparents, who are bargaining over the allocation of resources within the household, or the allocation of labor in the household. And there's opportunities for beneficial gain. Both persons can benefit from arriving at a bargain, but there's also a situation of conflict, in that sense that there's some zero-sum element to the bargaining problem. The more that one person gets, the less that another person might get. In this kind of situation, it's not like a market situation where people take the prices as given and then choose their optimal actions. Instead, in this kind of situation, the choice of one person depends on the choice of another person. So it's a complicated problem, and John Nash, back in the 1950s, was the first person to really sort of nicely formalize it in a useful way, and we're just going to introduce his formulation here and see what use it is for understanding inter-household issues. So we imagine two people bargaining over an outcome. These people have fallback options. That is, if the bargaining doesn't result in an agreement, then they have some other option that gives them a certain level of utility. Nash predicted that the outcome of the bargaining would be the outcome that maximized the product of the gains. We can make this concrete in mathematical terms with an expression where we have a problem to choose a value of x, the outcome, that maximizes the product of the gains. We imagine the gains to be the utility to person A from the bargain, from the outcome x, minus their fallback utility, we'll call that VA, and the gain for B is the utility of B with the outcome x minus B's fallback utility. So that's the product of the gain, and we can make this more concrete, but before doing that, let's have a brief digression. Nash proved in a straightforward bargaining problem that this would be the outcome with four relatively innocuous assumptions. The first assumption was the outcome of the bargaining had to be efficient. The second was that people valued the outcomes in terms of a ranking, so the level of their utility preference didn't matter, just the ranking that they had over different utilities for different outcomes is what mattered. Third assumption was that there's no bargaining power per se, that one person didn't have some special ability to bargain compared with the other person. And the fourth is what it's often called the independence of irrelevant alternatives, IRR assumption, which is that the outcome of the bargaining shouldn't be affected by a change in the possibilities that could be outcomes of the bargaining if those possibilities themselves wouldn't be selected in the outcome of the bargaining. So irrelevant extensions of possibilities shouldn't affect the outcome. That's a controversial assumption, because in real life we know that people often determine their utility based on reference points, and so adding options that won't be chosen might change people's reference points and thus might affect the outcomes of bargaining. So from the psychological point of view, that's probably not a great a realistic assumption, but turns out to make the math considerably simpler. So let's take a simple math version of this and imagine that two people are bargaining over splitting a cake. So person A is going to get the share S, and person B is going to get 1 minus S, whatever's left over. And we imagine they have their fallback options. If they don't agree on a bargain of the cake, then we imagine VA is equal to 1/3, and the fallback option for B is equal to 1/8. So here's the maximization problem, the product of the gains. We multiply it out, we take the derivative, set the derivative equal to 0, and we solve for s in order to find s that maximizes this function. We could, of course, plug that into Excel and try all kinds of different values of s until we found the value that maximized the function, but using calculus is a much more straightforward and easier way to figure out the value of s that maximizes this function. So we multiply it all out here. We take the derivative of this whole expression and we set it equal to 0 here. Then we do some rearranging. So we bring this 2s over to the other side, and I've done that reverse here. So we get 2s equals 12 eighths. 12 eighths is 8 eighths plus 4 eighths. So 12 eighths minus ½ is equal to 11 eighths. So now we divide both sides by 2. We get s is equals 11/16, and 1 minus s equals 5/16. So the point here, right, is that the fallback options determine the outcome of the bargaining, and that's the main lesson of the Nash bargaining solution. That threat points matter for the outcomes. In household bargaining, that's going to mean that divorce laws, alimony provisions, norms about marriage, assortative mating occurring in the marriage marketplace where people who are similar marry. In that case, there won't be a lot of differential bargaining power if they're both very similar. If we don't have assortative mating, so that, say, very rich men marry very young, uneducated girls, then we might imagine that bargaining power is very unequal. The threat points, that is, are very unequal in the marriage. And that's where household bargaining then would matter a lot. That's our brief introduction to the Nash bargaining solution.